Introduction to the World of Time with Critical Path Networks. In this lesson, we will uncover several of the secrets exposed by Kelly and Walker when they developed the critical path planning methods. We will begin the time analysis of the network, understand the forward pass, apply the rules and calculations, and develop the early start bar chart. So let us start with the activity box, and the first thing we're going to do is add the activity duration to the network, and that appears with a small number directly under the activity box. Then you'll notice that the activity box itself is broken up into 7 compartments. First we have the activity name at the top in the middle, and then there are 6 others. The ones that we are going to be concerned with during this exercise for the forward pass is first of all the one on the left, which is the early start of the activity, and then the one on the right, which is the early finish of the activity. The early start is the earliest an activity can start after completing all the predecessors. The early finish can be calculated. It's the earliest an activity can finish, and it's equal to the early start plus the duration. To begin the forward pass, we're going to start with finding out the earliest an activity can begin. And in order to do that, we have to apply the logic rules of networking. So for the early start, the logic rule is that all preceding activities must be completed before the activity can start. Once we've established that, we can apply a simple calculation to show us the earliest an activity can finish. And that calculation is the early start plus the duration will give us the early finish. Once we have the early finish, it is entered into the box on the right. And now we have the early performance of that activity. Note, there are only 2 things we need to remember for this forward pass, and that's the logic rule that all preceding activities must be complete, and the calculation, early start plus duration gives us early finish. So now let's go back to our little network we used as an example in the past. And the first thing we do is add the activity durations to the network. And these we'll put below each activity. Now we set the start of the project to time 0. And the first activity we're going to focus on will be activity A. Now the question becomes, what is the earliest we can start activity A? And the early start is the earliest an activity can start after completing all the predecessors. In this case, there is only one arrow coming into A, and that comes from the start node, which is set to 0. So we move the 0 into the early start of activity A. And now, focusing on activity A, we can calculate the early finish of A. And that will simply be the early start plus the duration. It's the earliest an activity can finish. So we calculate that by 1 added to the early start to give us the early finish of 1. Now this is where the real magic begins, because if we look at the start, the early start of A, we see that it starts at 0. And if we were to put a time scale at the bottom of the page and plot the early performance of A, it would start at its earliest start. And then if we added a bar for the duration, the length equal to the duration of the activity, we would end up at the earliest finish of 1. And this becomes the early start bar chart. It is the earliest performance of A plotted on a time scale. Notice that it is the result of the logic and sequence and the durations of the activities. Now looking at the early finish of activity A, we notice that there are 3 arrows going out of activity A. These go to activity B, C, and D. So the early start of activity B, C, and D is dependent on the early completion of A. So the logic tells us the earliest B can start, the earliest C can start, and the earliest D can start is as soon as activity A is complete. And A is complete at the earliest at time 1. So we move the 1 out to the next 3 activities. So now if we move our attention to activity B at the top of the page, we see that it has an early start of 1, which means that we can now calculate the early finish, because the early finish will be the early start plus the duration. So we add 6 to the 1 and get an early finish of 7. At this stage now, if we focus on the early start and look down to the bar chart, we realize that the earliest activity A can start on the bar chart will be at 1 as well. So we draw an arrow starting at 1, the earliest start, for the length of the duration, which is 6. As a result of that, we end up at the earliest finish. And we can check that we're correct because the earliest finish will be 7. And there we have the early performance of activity B on the early start bar chart. Now moving down to activity C, it has an early start of 1, so we can again calculate the early finish. In this case, the early finish is 4, the early start of 1 plus the duration of 3. And moving down to the bar chart, if we take the early start of 1, we can draw a bar for the length of the duration, which is 3 units, and we will end up at the early finish. We can check that we're right by examining the early finish, which is 4. And there we have the early performance of activity C, from the early start of 1 to the early finish of 4. And now moving down to activity D, we can calculate the early finish for D. The early finish for D will be the early start of 1 plus the duration of 1, which gives us an early finish of 2. And moving down to the bar chart at the bottom, we can start our arrow at the early start of 1 and draw a bar for the length of the duration, which is 1, and we will end up at the early finish of activity D. We can check by simply examining the early finish of D, which is 2. And there we have the early performance of activity D. And now looking at the next activity E, we realize we have to find the early start. Now the early start of E is dependent on the completion of the preceding activities, and in this case there is only one preceding activity, that is activity D. So the early start of E is dependent on the early completion of D. The earliest E can start is when D is complete at its earliest, which is 2. So we move the 2 into the early start of activity E. Having found the early start of E as 2, we can calculate the early finish of E. It will be the early start of 2 plus the duration of 2, which will give us an early finish for E of 4. Now focusing on the early start, we realize that we can start our bar on the bar chart below at the earliest start of 2, and then draw a bar for the length of the duration, which is also 2, and finish up at an early finish, which is 4. And checking that, we will see that our earliest finish is in fact 4 on the bar chart as well. And now moving up to activity F, we realize we have to find the early start for the activity. And the early start for F will be dependent on the completion of the predecessors. So the earliest we can start F is after the completion of B and the completion of C. And the earliest B and C will both be complete, will be at 7, the earliest completion of B. So we take the larger number of the two and we move that into the early start for activity F. So the earliest activity F can start will be at time 7. With an early start of 7, we can now calculate the early finish of activity F, and that will be the early start plus the duration. So the early start of 7 plus the duration of 2 will give us an early finish of 9 for activity F. And focusing on the early start, we realize we can start our bar on the bar chart below at the earliest at time 7, and then draw a bar for the length of the duration, which is 2, and we will end up at 9, the early finish. And checking our work, we'll examine the early finish of F and see that it is in fact 9. So the early performance of F will be from 7 to 9. Now, once we have completed the forward pass on all the activities in the network, we're in a position where we can find the shortest duration of the project, and that will be the early start of the end node. And the early start of the end node will be dependent on the completion of the two predecessors, activity F and activity E. And the earliest that both of those will be complete will be at the early finish of activity F, which is 9. So we move the 9 from the earliest finish of F into the earliest start of the end node. And there we have the minimum project duration of 9. So in summary, we start to realize that the forward pass really depends on remembering only a couple of things. The first is the logic rule, and that is that all preceding activities must be complete before an activity can start. And the second is one simple calculation. The early start plus the duration gives us the early finish. But now if we look at the results of the forward pass, we realize that we get the early performance of each activity. And there's no indecision about where the bars should or could appear on the bar chart. We simply place them at their earliest performance as calculated. And more important than that, we get the shortest project duration. And in the following lessons and the experience you gain by applying these techniques, you will start to realize the importance of that shortest project duration.